In this video, we're just going to do a brief reminder of discontinuity and continuity. So we've got here just a quick picture of the four types of discontinuity. We've got the removable discontinuity. This is the one that's the easiest to fix and the only one in which the limit exists. Removable, it has a hole there, but the limit exists because it's approaching the same spot from either side. Okay? We've got the jump discontinuity, obviously named, right? We've got the infinite discontinuity, named for asymptotic behavior. And we've got the oscillating. When we don't know what's happening because it's spiking back and forth so quickly. These are our four types of discontinuities: removable, jump, infinite, oscillating. Remember, this one is the one that we kind of say is different because the limit exists in that one only. The others, the limit does not exist at the spot of discontinuity either. Okay, let's talk about continuity. How do we prove something is continuous? Well, there are four steps to proving something is continuous. First, prove that the limit exists. I'm going to just name it like a point. Prove it exists from the negative side. Prove it exists from the positive side. Now that leads to your last step, which is, therefore, you can verify that if the limit exists from both sides, verify that they're the same, and therefore the limit exists at f of x. Because remember, the limit from the left side, the right side, for the limit overall to exist, the limit from the left and right must be the same. And finally, verify that the value of the limit is equal to the value of the function. Okay, let's pick a spot. I'm going to pick x equals -1. Okay, we're going to show it's continuous there. So the limit from the negative side is 4. That's the limit as we approach from the negative side. The limit from the positive side is also 4. Okay, now I should be going in here and actually changing these to -1s. Okay, like that. So what's the limit at -1? Well, since it's 4 from both directions, the limit is 4. Now, the value of the limit is 4. What's the value of the actual function there? Well, it's a closed circle. F of -1 is 4, so it's equal to the limit, which we already said existed, therefore we have proved continuity. So you can look at some of these obvious other spots, like here the limit exists from the left and right, but the limit doesn't exist because it doesn't approach the same spot. The same thing is true here. Here, the limit at 4, the limit exists from the left, it exists from the right, so the limit exists because it approaches the same thing from both sides. However, the value of the function isn't equal to the limit's value. So it wouldn't be continuous there. Now finally, just to be clarify a little bit more, you can be continuous from either the left or right side depending on whether there's a closed circle or an open circle. For example, this is continuous from the left right here because there's a closed circle there. That's left continuous. This spot, however, is not. This is right continuous because there's a closed circle from the right side. So just a little more clarification on continuity. This definition we don't use very often.